Good morning. Good morning to everybody. I'm Andrea Pagan from Carel. I'm marketing manager related to ventilation application for Carel. Today, in the next 20 minutes, we would like to present some advice, some suggestion regarding how we can bring hygienic, efficient, smart solution to a ventilation system in order to face the limitation that comes after the pandemic and that makes ventilation so important for the comfort and well-being of people. So ventilation, we are pretty sure that about the role of ventilation in order to ensure the right health and well-being in confined space, ensuring the right indoor air quality. In the past, probably when we design HVAC system, we stay very focused about the first 2 points, comfort and energy efficiency, that are crucial for the HVAC. But probably now we have to take into account another value that drives our choice. So it is health, the capability of the ventilation system to participate in order to make the space in which we live more healthier than in the past. But sometimes comfort, efficiency, and health could drive to different direction, and that probably we need to find the right balance among health and efficiency. We try to make a comparison with our simulation tools in order to ensure that we can find a balance among the way in which we designed the R&D unit and the ventilation system just before the pandemic, during the pandemic, according to the guidelines that comes from the regulation and institution, and then what we can do after, and which could be the suggestion in order to get health and energy efficiency system. The increased amount of fresh air could drive an increase of energy consumption for sure. Norm for non-residential ventilation promotes energy efficiency through the introduction of the heat recovery system, of course, with a certain level of thermal efficiency, and also introducing some recommendation, for example, the use of indirect evaporative cooling on the exhaust air in order to increase the efficiency of heat recovery systems. Ventilation also could have effects on the humidity level. We have the possibility during the winter time that introducing a great amount of fresh air can reduce the humidity level inside the room due to the fact that we are going to increase the temperature with the heating system. This could drive to different issues. One is the increase of energy consumption because we need to increase the humidity inside the room. On the other hand, low level of humidity could drive some issues in terms of health of people that spend the time inside the buildings. Let me play a video that can give some ideas of which are the effects of a low humidity level inside a building.
Air humidity has a direct effect on human health, with the greatest benefits in the range between 40 and 60%. The first line of defense of our airways is a physical-chemical barrier. The respiratory mucosa consists of a layer of ciliated epithelial cells that move mucus over their surface. This mucus then carries viruses, bacteria, and other pathogens away from the lungs. When humidity is low, this layer of mucus is thinner and denser, reducing ciliary motility and increasing the risk of pathogens infecting the epithelial cells. When this happens, the second line of immune defense kicks in. This is an innate response. Macrophages are called to the affected area, recognize foreign substances, and eliminate pathogens through phagocytosis. When humidity is low, the likelihood of respiratory infections increases, requiring the immune system to work much harder.
So now we understand how humidity is important for the health of people to spend time inside the building. But not only health is important, it's also important that to keep the hygienic level of the equipment that is interested in the ventilation system have to keep and maintain a certain level of quality due to the fact that we don't want that the air we supply can be deteriorated by air handling system itself. VDI norm is the norm that regulates and gives instruction on how we can design this kind of systems. And this affects especially some of the components that basically equip an air handling system. So, for example, the heat recovery, the humidification that has to be designed in a certain way, they use a certain kind of materials, but also the control of operation of the air handling unit. They need to be kept and put in operation some automatic logics that keep the unit hygienically safe. So then comes the pandemics 2 years ago. Now we are trying to go out of these terrible issues. But during the pandemic, some ideas are introduced in order to manage the ventilation systems. For example, ensuring as much as possible the introduction of outside air, even 24 hours per day. The safe use of heat recovery system that makes some restriction in designing and using and operating the heat recovery itself. And also the guarantee the minimum humidity level. Below 40% of relative humidity, we can see the risk that we have presented in the previous videos. So all these drivers, all this decision drives the design of ventilation system in a direction in terms of energy consumption that cannot be sustainable in the long term. So on one hand, we have the requirement of energy efficiency that becomes more and more important even in this period during this crisis of acquiring source of energy. On the other hand, we need to take into consideration which is the restriction and the limits that come in terms of health and efficiency of the system. So we try to make some simulation presenting as typical ventilation systems working in three different operating conditions. One that is typical for pre-pandemic, another one that is defined according to the pandemic condition given by the different guidelines that appears during that terrible period. And after that, we would like to present another operating condition in which take into consideration that we are going to use some components that are specifically designed in order to keep on one side energy efficiency, on the other side healthy condition, we can drive to some interesting results. We base our consideration on the condition of Milan, but then we extend it to other climatic conditions of other countries. So comparing the two operating conditions from pre-pandemic to pandemic, okay, we designed. These are the assumptions that we can take. We can see that the result in terms of energy consumption could lead that during the pandemic, with the pandemic operating condition, the energy consumption is very high. So the cost could increase a lot if we would like to keep that level of health and hygienic condition. So now we try to see what we can do in terms of having some components that is designed for health and efficiency operating condition. One, for example, using plate heat exchanger. This is the model designed by Recuperator, a company that belongs to Cara Group, that is designed with a near zero leakage. So the possibility to use heat cross-plate heat recovery system without any leakaging between the two airflows that pass through. It is a component that is designed and certified according to the VDI norms. So it is certified to be used in application even demanding in terms of hygienic condition. On the other hand, it is also designed for being used with the indirect evaporative cooling application. So the coating that is used for this kind of heat exchanger can support very well and can enhance the effect of the indirect evaporative cooling with the heat recovery systems. Another component that we can take care about the design characteristic is the high-pressure water atomizer used both for humidifying and make direct evaporative cooling on the supply air, and on the other hand, on the exhaust air, providing the indirect evaporative cooling. All these things can be done with only single one equipment, with continuous capacity modulation in order to adapt the capacity of the and the modulation of the capacity according to the different airflow, to various airflow. And also, due to the fact that is an adiabatic system, the power consumption in order to provide, to increase the humidity level is very low, only 4 watt per liters of sprayed water. All these components are, of course, all certified according to the hygienic certification like VDI. The other component that we take care is the solution for the automatic logic that drives all the ventilation system, providing a solution that is able to manage the unit with the very smart logic that are designed in order to achieve the maximum indoor air quality, to operate the different devices and to activate the different devices in order to reduce as much as possible the energy consumption, minimize the energy consumption of the unit, and also able to introduce some logic in accordance to the norms. So introducing some program that we call as VDI program that is able to activate the unit in order to ensure to reduce any kind of risk of having wet inside the unit, and so reducing the possibility of proliferation of bacteria. Another interesting point is everything now is IoT, and everything now is designed as to be smart. So it is important also that the ventilation system becomes smart. And in order to make the ventilation system become smart, it is important that we have the full access from remote to the control system. So we would like to have remote control to the unit via secure ET connection in order to manage the unit even in a crisis situation in which we would like to switch from one operating way, for example, the one just before the pandemic, to a critical situation in which we would like to enhance the capability of the unit to provide as much as possible healthy and hygienic conditions inside the building. Acquiring information about the condition of the system in order to monitoring if there are some reduction of the operating condition of the system itself, and also being able to acquiring data in order to assessing the performance of the unit and being able to check if there are some deterioration about their operating as we design. So this is the scenario that we try to explore with our tools, with adding all these new devices and also considering these new logics that we would like to implement. And as we can see, we can have some benefits. We can try to keep the consumption regarding the ventilation system in a reasonable level, similar to what we have pre-pandemic. So we are able to get a balance between efficiency, that is the target that we used to have just before the pandemic, and also the hygienic condition of the system, using this suggestion in terms of features of the component that compose the ventilation system itself. So this kind of scenario was spread in a different climatic condition, and we can see that the benefits is basically in a certain level, even in cities and climatic condition of different countries. So we can consider that this can be spread in different part of the system installed in different part of the world. So, trying to get the conclusion, ventilation is an essential strategies. We have the awareness that is essential strategies to ensure adequate indoor air quality for considering health, well-being, and safety in the confined space. Okay. We have understood that we need to introduce more stringent requirements in terms of health condition for the building, but on the other hand, this requirement increased energy consumption, and this cannot be sustainable for the long term. So it is important to make a step ahead, to define a new design approach, trying to choose components like heat recovery, adiabatic and adiabatic humidification, and direct evaporative cooling, control systems, supervisory system dedicated to the R&D units that are able to meet this stringent condition with a proper energy efficiency. Carel is a partner that can assist in this sense OEM manufacturer, designer that will like to exploit this particular condition in order to create a better air handling system. These technologies are we put on your side our technology and expertise in order to get this important target like health and energy efficiency. I will invite you to visit our booth that is just close to this stand, and then I would like to thank you for the attention.